because again, you just don't want anybody to be exposed for a long time. So you have fast track construction, which leads to, thinking about prefabricated structures. So all these have become strong now because of the COVID situation. So friends, human mentality is that, we are very good at adopting, and you people who will be graduating soon will also have to adopt to these things. And you people are really good at adopting than people at my age. So please look at the positives from all those weaknesses and then try to arrive at things. So with this brief introduction, I go on to my presentation. And when I say, so basically what I wanted to mention to you is that infrastructure is the order of the day, which means civil engineers have big role to play. And when we say civil engineers, you will notice that it is the geotechnical engineers who are always the first people to arrive at in any of the civil engineering projects. Therefore, geotechnical engineering has its own value. So in this presentation, I'm talking about the importance of geotechnical engineering, the relevance of soil investigation, and then I'll show you one case study of one of the buildings which collapsed in China, in the city Shanghai. And maybe I'll talk about different types of foundations. I think by then, the time will be up. But in case possible, if I'm going faster, I may cover a couple of more subjects. Here, my intention is not to cover too much. My intention is to make an impact to you that geotechnical engineering is one of the very important subjects in civil engineering. And without that, no civil engineering structure can exist. And geotechnical engineers today have much bigger roles to play. And day by day, the opportunities to geotechnical engineering is continuously increasing. Well, so let us go with some introduction to geotechnical engineering. Okay, students, you all have been exposed to some of the construction and materials, some of the structures, maybe a steel structure, maybe a RCC structure, maybe a frame structure, maybe a masonry structure. Okay. If I ask you to name a few constructional materials, very quickly you say that cement is a good construction material. Concrete is one of the most important construction materials. Steel is another important material of construction. But very few people say that soil is also a construction material. Friends, I would like to tell you that soil is not just a construction material. It is the most used construction material. Why? If I want to build an earthen dam, entire dam is built out of soil. If I want to build an embankment for road or railway track, entire embankment is built out of soil. If I have a retaining wall and I need to fill on the back side of retaining wall, on the rear side of retaining wall with the backfill, entire backfill portion is soil. So I make this statement that soil is the most common, most used, and least expensive construction material. Why most common? You don't have to manufacture soil like you do with concrete, you do with steel. Most used. So if you see the quantity of soil used as a construction material, quantity of other materials used, no comparison. Soil is much, much more used compared to maybe concrete. Even brick or tile is made out of soil. And lastly, I said least expensive. Why? You don't have to manufacture soil. It is already available in nature. You just have to pick it up. Sometimes soil at a particular place may not be good, so you may have to pick from some other place and bring it. So you may have to spend a little on transportation. So soil is the most common, most used and least expensive construction material. In addition, whatever you build, whether it's a bridge, whether it is a road, a building, a stadium, a temple, anything, it has to be built on ground. So ground is made of soil. So everything has to be built on the soil itself. Therefore, I make the statement that it is very, very important to civil engineers. Most important construction materials and most wanted by civil engineers. It has many special qualities like I mentioned earlier. It is the oldest construction material. How old is it? As old as human beings. When Adam and Eve were born, maybe, the first thing they did was they were looking for shelter for themselves. Maybe they used caves as shelter. So caves are made of rocks. So that is when man started using soil as a construction material. So it is the oldest construction material. As I said, you don't have to manufacture it. It is readily available. It is cheap or available free of cost because, you don't have to buy it. It's available everywhere. I'll tell you in one of my next slides that it is the most complex of all the construction materials. What do I mean by complex? Difficult to understand. But today, you can modify the properties of soil to suit your requirements. You can do some things, you can add some chemical, you can use some physical means to modify the properties, whatever property is there, to change the properties such that, you get it to the use of your requirement. So that we call as, ground modification or ground improvement. So in that respect, soil, today is easily modifiable because of the improved technology. So I have a definition for soil here. And if you see microscopically, a soil would look something like this. A soil mass would look something like this. So what does it comprise of? You can see that it comprises of the solids of different shapes, sizes. In between these solids, a lot of void space is there. And that void space is sometimes filled with water, sometimes it is filled with air, and sometimes it is filled with both water and air. And all these are compact, connected by the number of contacts between the solids. So we say that soil is an uncemented aggregate. That means, you can separate the particles. It has some partial cementation due to what we call as cohesion. Still, you can separate out the particles. So it is an uncemented aggregate of mineral grains and sometimes, decayed organic matter. In general, we call them as solid particles, along with liquid, that is water, and gas, that is air. In the empty spaces, these liquid and gases are in the empty spaces between the solid particles. How are these soils formed? They are formed by the weathering action on the rocks and at the top of the surface. So they are generally found at the top of the surface. So slowly the rock below will get weathered away due to the weathering action. So slowly it gets converted into soil. So you can see soil here, soil mass. Microscopically it looks like this, but otherwise soil mass would be something like this. Where do you use soil? What are its applications? I've just listed a couple of these applications. You require soil to manufacture bricks, tiles, and earthenware. You know, why do you use bricks for? You know, why do you use tiles for? And what are the applications of earthenware? So all these materials, are mostly made up of soil. More than 95%, they're made up of soil. So manufacturing of these things is done using soil. As I said earlier, everything you build has to stand on ground, that means on soil. Therefore, soil acts as a foundation material. So you're going to rest everything on the soil. So soil is a foundation material. I also mentioned about dams and earthen embankments. You know why you require dams? Many of the dams are made out of earth. You call them as earthen dams. There are a few dams which are made out of rocks. You call them as rock-filled dams. So these earthen dams and rock-filled dams are completely made out of soil. Entire volume of this will be soil itself. So is the case with embankments. You may have embankments to carry a road, to carry a railway track, or to separate out two regions. An entire embankment will be made out of soil. So you use soil to construct dams and embankments. You also require soil to fill the hollow places. For example, you make a trench in the ground and build your foundation. After the foundation is built, the open spaces, whatever are left, they are filled with soil. Then you have retaining walls. This is a retaining wall. What does a retaining wall do? It retains earth at two different levels. This is the topmost part. So here you are retaining earth up to this level, and on the other side you are going to retain the earth at this level. So to fill up this portion, to fill up the back portion of the retaining wall, which you call as backfill, you use soil. Sometimes, you want to build a new locality, new residential area, let's say, and you see that the ground is not level. Normally, we may not like if it is not level, if it is having too much of undulations, and you want to fill up that portion and bring it down to some level. Then also you use soil. So soil is a very good fill material. And today, you are going to dump wastes also on soil. So soil has to, bear the load of not just a building, but also wastes. So you have landfills which are developed, which are designed, constructed, considering all environmental aspects. But these landfills are made of soil again. So likewise, soil has many, many applications, and hence I want to tell you that it is most important to civil engineers. As I said earlier, soil, if you see, is not homogeneous. If you see microscopically, it has solid particles, lot of, void space in between them, and that void space is filled with air, water, sometimes both of them. So this makes soil very, very complex because they are not connected together. They are not, glued together. The connection is only through contact. And contact is not at many places. So each particle of soil have some contact, some places of contact. And the shape of each particle, the size of each particle will be very, very different. Therefore, there is every possibility that you can dislodge, displace them. You can make them experience relative movement. And hence, soils are not going to be same from place to place. And at the same place, with change in time, there is every possibility that soil particles may go to new or equilibrium position. So that makes things very complicated. So I always say that soil is the most complex construction material. To understand it better, to represent it in an easier way, a soil mass of some volume here, like you can see here, this is the volume of soil mass, which comprises of solid particles, water in the open space, in the void space, also air in the void space. So you can consider this total volume and then distribute, okay, into solids, water and air for convenience. So all that quantity of solids I packed together and placed here, and this is the amount of solids. All that water is available, whatever is available, I put them together here, and this is water and this is air. I can measure these either with respect to volume or with respect to weight. And hence, we call this as a three-phase system. This is the kind of idealization of the actual situation. And such idealization will help in understanding about soil better to quantify certain things. Such idealization is required. I told you that soil is the most complex construction material. You compare it with steel, you compare it with concrete. Steel and concrete are much easily understood. You can exactly say how much load a steel rod can take, how much tension it can take if I give you the diameter of that. You can also say what is the compressive strength of concrete, given concrete. But to assess the strength, the durability, the capacity of soil is very, very difficult. Sometimes next to impossible. Because its properties depend on several things. It is not just the present situation, the past condition in which the soil existed, the environmental action, the several other things, okay, make soil very, very complicated and difficult to understand. I've tried to mention all or some of those properties which make soil very, very complex. I can spend a lot of time talking about this, but today I just want to move forward. So soil is porous because voids are there. That makes it complicated. It exists in different forms, different phases. If any liquid is there, you can see that liquid passes from one end to another. Permeability is there. And soil is always particulate in nature. So likewise, you can keep on talking about the complex, phenomena which make soil difficult to understand. But friends, I also would like to tell you that soil is a smart material. Soil is a clever material. And I can give you reasons for that. I hope you all agree with me that soil is colorful. Soil exists in different colors. You have red soil, you have black soil, you have gray colored soil, you have light colored soil, dark colored soil. It's available in multicolor. 2, you agree that soil is sensitive. What do I mean by sensitive? It gets disturbed when you disturb it. Intact in its position, soil will have some strength. But if you just disturb and bring it out of its place, it will lose its strength. Some soils will lose all their strength when they are taken out. Such soils are called hypersensitive clays. Otherwise also, most soils do lose their strength. Whatever strength they have intact in their place gets reduced. You know, soil has memory. It knows exactly what load, what pressure it was subjected to before. If the present pressure is more, it behaves in some way. If the present pressure is less, its behavior is totally different. It is explained through E log P curve. Some of you may have forgotten Professor K. Prakash. Professor K. Prakash teaches with lot of pride, happiness, consolidation theory, in which he researched a lot and got a lot of accomplishments. And he always teaches about E log P curve. And from E log P curve, in consolidation theory, we can show that soil has memory. It knows exactly the pressure it was subjected to before, and the present pressure, if it is more, it behaves in some way. If it is less, it behaves in a different way. Fourthly, soil changes its properties with time. If I take water content in soil, during summer, water content will be different. Same soil, same place. During rainy season, water content will be totally different. So depending on the time, depending on the season, the properties of soil, even bulk density, they change. Why I mentioned all these things? All these are the properties of human beings also. I hope all of you agree with me that we human beings are colorful. We are sensitive. Some are more sensitive, some are less sensitive, but human beings are sensitive. Hopefully, we all possess memory. And we change our properties with time. I always give the examples of our politicians. Morning, they make some statement. The statement they make in the afternoon would be totally contradicting that. Again, in the evening, it could be a totally different statement. So, we human beings, keep, changing our properties, and hence, we can say that we human beings have lot of resemblance with soil. So, friends, I want to say that, like human beings, soil is a smart material. What do I want to infer from that? I would like to tell you that you have to respect soil. You have to understand soil very well. If you disrespect, if you don't understand it well, it will hit back, it will show its anger. How does it show? In the form of failures. On the other hand, if you respect it, it will be very happy. It performs to your, expectations, or even better. So, whenever you deal with soil, don't be careless. Give proper value to it. It behaves according to your taste. Maybe you are not an expert in geotechnical engineering. You need not be. Not everybody needs to be an expert. You should be able to understand whether it is a good soil or not so good soil. If it is a good soil, easy to handle, don't bother. You can do the things, as you plan. In case you find that it is not a good soil, don't take the decision by yourself. You please consult an expert. And hence, let the expert evaluate what is the status of the soil and what changes are required, and use the recommendations carefully. So, this is about soil as a complex material, as an intelligent material. Well, friends, I talked about infrastructure. It could be roads, it could be buildings, it could be bridges, it could be any, thing which will help the mankind in, becoming more and more comfortable, improving their luxury, improving their comfort. So whenever you talk about infrastructure, it is civil engineers who always play a major role. Only when civil engineers complete their work, all other engineers take off. So you know the value of civil engineers. And today, you cannot build any structure in air. I don't know when you become, experienced civil engineers, who knows, you might be able to build your structures in air also. But as on today, we can't build our structures in air. So they have to be built on ground. So I tell that always any civil engineering construction should start from ground. Therefore, geotechnical engineers are the first people who will arrive at any construction site. That is the importance of geotechnical engineering. Normally, if I take any civil engineering project, these are the steps to be followed. Whether it is a big project, small project, medium level project, whether it is a project in an urban area or a rural place, whether it is a dam site, okay, you're going to follow these procedures. In some of them, you follow it very quickly, but these procedures are necessary. What is that you need to do? I'm talking about the substructure. As Professor Raghu Prasad mentioned, broadly you can classify a structure into one which comes on top, above the ground superstructure, one which is below the substructure. So you need to first of all decide at what depth you start your foundation. That requires, not just structural engineering knowledge. That requires a knowledge about the site. So you have to decide what is the depth at which the foundation is put, which is a fairly big challenge. Maybe for ordinary buildings, you may be able to do that. But today you don't have only ordinary buildings. You have buildings, which are tall, which are complicated, which are not symmetric, and several things. So you need to decide at what depth you want to build the foundation. At the foundation level, you need to collect sample. You also may do the field tests, like plate load test, standard penetration test, and collected samples are taken into the laboratory. You collect both undisturbed samples as well as disturbed samples. And then, you take them to the laboratory, and in the laboratory, you do the testing. First of the testings include the testings for index property determination, because you require to classify the soil. You require to identify them. And after the index properties, you do the subsequent tests. In case you want to build a house or build a structure, you need to design a foundation which requires SBC, safe bearing capacity of soil. In case you would like to use that soil for, building an embankment, building a dam, then you need to know the compaction characteristics. You also may want to know what's the amount of settlement. You need consolidation characteristics. And in a dam, you want to know how much is the permeability, how much is the water coming out from one end to another end. So you require permeability characteristics. So you decide what are the things required. Accordingly, you do the tests in the laboratory and hence prepare a nice report. A soil report is very essential. A soil report is prepared, and that soil report will be data input in the design office. If you are designing a foundation, then you require the input from that soil report and hence design. You may design a retaining wall, you may design a slope, you may design a underground structure, whatever, So you require the inputs from the soil report, and once it is designed, You prepare the drawings and go back to the field to the same place for the construction. So this is a cycle. What is that you do? Just a minute. So you locate the level at which the foundation is to be put, take samples from there, conduct field tests also. Collected samples are taken to the laboratory and you perform tests, prepare a soil report. That report will be input in a design office. You design the geotechnical structure. I call them as geotechnical structures. Prepare the drawing, go back to the field and do the construction. This is a complete geotechnical project. So depending on the size of the project, you require to do it more and more rigorously. As I said, geotechnical engineering is a vast field today. I remember my days when I was a student at SJCE only, way back between 78 and 82. First year I studied in Mandya. Therefore, I studied only 4 years at SJCE. My time it was 5 years course, unlike now. And we used to have 2 courses of geotechnical engineering. The first course was called soil mechanics. The second course was called foundation engineering. Why foundation engineering? Because at that time, emphasis was foundations. People said, geotechnical engineer means his job is only foundations. But today, geotechnical engineer is not restricted to only foundations. He deals with many structures like, retaining walls, earth dams, rockfill dams, embankments, canals, roads, sloping grounds, tunnels, landfills. I can keep on telling. All these are the structures which have to be designed and constructed, taking note of properties of soil. They can be designed only when you know about the properties of soil with which they are in contact. So such structures, I in general call them as geotechnical structures. And today, you have plenty of geotechnical structures. Therefore, geotechnical engineering has grown leaps and bounds. And you probably keep getting new and new idea with the improvement in technology, passage of time, and so on. Earlier days, when I was doing my post-graduation, MTech, in geotechnical engineering, I used to have 10 courses, out of them maybe 5 courses only geotechnical. I used to take, other courses from other sub-branches. Could be hydraulics, could be structural engineering, could be even, computer engineering. But today, you have so many topics. You can even form a undergraduate program. But definitely no problem at all with respect to MTech program. You can have each of these subjects which I have mentioned, as one complete course for 6 months, or sometimes even more. Foundation engineering, deep excavation, tunneling, retaining structures, slopes, embankments, environmental geotechnical engineering, earthquake geotechnical engineering, structures in difficult conditions, ground improvement technique, rock mechanics, engineering, geology, plenty of them. So that's the kind of growth geotechnical engineering has made over the years. I said, soil is the most complex material. The reason is its properties are never uniform. It is neither homogeneous nor isotropic. In the same place, in 2 different directions, its properties are different. And maybe at the same depth, at 2 different places, also the properties are different. In India, I just tried to list a few treacherous soils. What is a treacherous soil? A difficult soil to handle. So some of the difficult soils to handle are listed here from Indian point of view. You have marine clay. Automatically when I say marine, it means, clay in the coastal region. So clay or soil available in the coastal region. What is the biggest problem with that? Number one, it is in marine environment. That means, salty. So because it is salty, any structure you build, whether it is concrete, steel structure, the material of concrete or steel gets affected by it. For instance, corrosion is a common thing in marine environment. So we'll have to take care of that. More than that, from geotechnical engineering point of view, marine clay has huge amount of settlement problem. Whenever you deal with marine clay, whenever you want to build a new structure on marine clay, the biggest challenge for you is to compute the probable settlement. If the settlement is within limits, you don't have to bother. But most of the times you will notice that the settlement will be out of limits. So settlement is the biggest culprit in case of marine clay. And you have alluvial soil. Alluvial soil is one which is transported by water, river. Okay, so it is generally found on the banks of the rivers. Indo-Gangetic plain, huge on either side, you have alluvial soil. Even Kaveri Basin, you have alluvial soil. The problem with alluvial soil is that it has very low bearing capacity. And also it is prone to settlement. So you need to think about some kind of a, understanding as to how much the bearing capacity of the soil is, how much is the possible settlement, and how you can improve that. You have desert sand over Rajasthan and Gujarat, northern Gujarat. Desert sand is, very fine sand. And its SBC also is low. Fortunately, we don't have big cities around in desert area. If you had big cities, multi-storied buildings, there is a difficult thing. And in desert sand, you have to really take challenges because, you go any depth, the same soil exists. So, and then, there is no water, fortunately, there. I always say that water is the worst enemy to geotechnical engineers. If there were to be no water, there wouldn't have been geotechnical engineering also. So always, whenever the soil is in contact with water, you have more and more problems. And hence you come across expansive soils. In India, you call them as BC soil, black cotton soil, Indian black cotton soil. You can see a lot of black cotton soil regions in Maharashtra, Karnataka, also in Tamil Nadu. So what is the problem with expansive soil, BC soil? It has affinity to water. It has love towards water. Whenever water is available, it simply drinks water. When it drinks water, it swells. When water goes out, it shrinks. So it experiences alternate swelling and shrinkage depending on the presence and absence of water, and hence experiences huge amount of volume change. Any structure built on such soils will also be exposed to expansive soil. So any structure which is built on such soil, definitely when the soil swells or shrinks, the structure will be subjected to vertical movements. And if it is a light structure, it is more prone to problems. And we deal with a lot of expansive soils in and around Mysore city, especially in rural areas. And that is a big challenge. And then you have lateritic soil. Laterites are found in coastal Karnataka. Laterites are also found in Bidar area. It's very beautiful, red in color, very sturdy, strong.
Good evening, everyone. Myself, Arun Sidhi.
Well, good morning to one and all who have joined us today in this webinar. I, Rupapriya JK, a civil engineering, will be your MC for the day. Respected guest, Dr. Manoj Kumar B, Dean Academics, Dr. H.S. Dayananda, HOD of Civil Engineering, Dr. S.K. Prasad, and all my dear participants.
Science, so thanks to everyone. It is only the possible understand our role.
जी सर जगदीश गोदिहाल पूछ रहे हैं व्हाट आर द चैलेंजेस इन अर्बन लेक्स रिजुविनेशन हाउ इट कैन बी ओवरकम
Yes, the urban water bodies, the soil, there the scarcity of water. There is the. Thank you very much.
Oh. Thank you, sir. So before we close, I wish to share something with you. Sir? Rajendra, sir? Okay. Parasji? Okay. Okay, so we had something to show Rajendra Singh sir, but I think he had to leave. So probably we will have to wrap up now. Yes. So should we continue with vote of thanks?
Yeah, please continue with vote of thanks.
Okay, okay. All right. So now I request our respected Dean Academics, Dr. H.S. Dayananda, to kindly propose vote of thanks.
Good afternoon, everybody. It is my privilege to propose vote of thanks to the two resource persons of today's webinar, participants, each and everyone who have contributed for the overwhelming success of this webinar on the occasion of birthday celebration month of Dr. Rajendra Singh, who is popularly known as Waterman of India. At the very outset, I express my sincere, heartfelt thanks to Dr. Rajendra Singh